Okay guys, here comes my second example for Pythagorean theorem. Now this time we're looking for one of the short legs in the triangle, and the triangle is labeled GHF this time. Remember I said they're not always going to be labeled A squared, B squared, C squared, or ABC. So what side fits with what? Well, remember C in the formula is always the longest side of the triangle. So in this case it's going to be H. A and B are always the short sides of the triangle, and it doesn't really matter which one is which. So I could say A is this side, it would be little f, or I could say A is this side, call it little g. All right, so I'm going to fill in the stuff that I know in the formula. I don't know f, so I'll put that in place for A. F squared plus the one I'll put in place for B, which is this one, G, 6 squared. The square of the two short sides added together has to be equal to the square of the longer side. So 7.2 squared. Okay, now I can break out my calculator and I can do the square on those. F squared plus 36 is equal to 51.84. Okay, I did it on my calculator before I recorded. Now, how do I find out what f squared is equal to? F squared plus 36 is equal to 51.84, so opposite operation of adding 36 would be subtract 36. F squared is 51.84 minus 36. You might not write that step. You might just carry it out on your calculator. Say f squared is equal to 15.84. And opposite operation of squaring, f squared is take the square root. So f is the square root of 15.84. And that worked out to 3.98. Now, I said before, I like to keep the same number of decimal places that they showed me in the question. This one had 1 decimal place in the question. If I rounded this off to 4, it might look like I was saying, oh, the side length for F is exactly 4. But it's not. It's a little bit shorter than 4, and I want to make sure that that's clear to whoever's reading my math. So I'm just going to leave it as 3.98. Okay? If you said 4, I'd probably give you the mark. Short side on this triangle, F, is just under 4.